Assalamualaikum and hi, my name is Muhammad AKRAM. So for the process description, biodiesel is a form of diesel fuel manufactured from vegetable oils, animal fats or recycled restaurant greases. There are various processes involved in biodiesel plant UTHM. So the esterification process occurs at VE201. This process happens when substance interaction between acid catalyzed and methanol. During the esterification of FFA to biodiesel, an acid transesterification of triglyceride takes place. FAME, which is a fatty acid methyl ester, is the desired product in the esterification along with the reducing the FFA content. Okay, next at VE202, there is a process called transesterification. There are first and second process of transesterification. So the first process happen when substance interaction which are methanol and base catalyzed. So during the first transesterification, the acid catalyzed resulted from the previous esterification must be first neutralized. So the first transesterification is able to produce up 88% conversion of triglycerides to biodiesel. In the same vessel, the second process is accomplished to complete truly the reaction to a higher conversion of oil to the biodiesel product. After 1 hour retention time of the second step transesterification, 95% conversion of triglycerides to biodiesel has been achieved.
Assalamualaikum, my name is FITRI bin Muhammad Rizalli, DD210078. So today I'm gonna tell the process that happened at V203 and T209. First, the biodiesel will go through a polishing, washing and drying process at VE203 in order to remove any catalyst, residue and contaminants from the finished product. And then the finished product later will be placed in a storage tank which is at T209. That's all. Thank you.
For equipment and line, for this project, we have used a few equipment and few lines. For equipment, first we have vessel and tank. For vessel, we use a VE201, VE202, and VE203. For tank, we use a T209. Next, for pump, in this project, we use a centrifugal pump. Next, for valve, we have used 4 valve, control valve, globe valve, check valve, and gate valve. For pipe, we have used two type or two size of pipe, which is 2-inch and 4-inch of CS300. And lastly, the equipment for this project is heat exchanger. Next, for lines, we have 3 color of line, which is red, blue, and black. The red color will represent 4 bar and 2 bar of steam. The blue one will represent water, and lastly, the black color will represent oil.
Okay, so for the control loop is the fundamental building block of control systems. It consists of all the physical components and control functions necessary to automatically adjust the value of a measure process variables PV to equal the value of a desired checkpoint SP. It includes the process sensor, the controller function, and the final control element FCE, which are all required for automatic control. Supervisory control and data acquisition SCADA is a control system architecture comprising computers, network data communications, and graphical user interface for high-level supervision of machine and processes. It also covers sensor and other devices such as programmable logic controllers (PLC) which interface with process plants or machinery.
Assalamualaikum. My name Ahmad RAFIQ bin AZMAN. Number metric DD210071. So safety in our PNID project, Firstly, we have bypass. So we know bypass function is allow for the division or temporary isolation of a component or section of a process system. So it provides an alternative pathway for the flow of fluid or materials when need, bypassing the normal path. And we know bypass line or valve may be used during system startup or shutdown to facilitate the control flow of fluid. So by utilizing bypass, operator can smoother transition and preventing abrupt pressure or flow change. And lastly, bypass can be beneficial during troubleshooting procedure. They enable operator to isolate specific component or section of the process system to identify and rectify issues without interrupting the overall operation. And also at bypass, we also have a temperature indicator, which is we know that temperature indicator is a symbol or representation on a PNID that denotes the presence and isolation and location of a temperature measurement device within a process system. It indicates where temperature data is being monitored or controlled. So when these two elements, which is bypass and temperature indicator, are combined on a PNID, it usually indicates the presence of a bypass line or valve that allow the division of fluid flow around a temperature measurement point. So at the first drawing picture, PNID1, we can see here we have two bypass, which is the first bypass that entry to VE210, and also we have a temperature indicator. And second bypass, we have enter at VE202, and plus we have a temperature indicator, which is both are from steam. So the PNID drawing 2, at first we can see here we have a steam bypass plus with a temperature indicator that enter to VE203, and then at the top one we have a water bypass that go to heat exchanger 203, and then go to 10209, and the last one at the bottom, this is a final product, which is oil bypass that go through pump 203 and then to heat exchanger 203, and lastly go into T209.